Hi, this is Miss Carly, and this is your flip video for solving quadratic equations by graphing and by factoring. Behind me, I have two examples. One of the reasons I would probably try to use the calculator to solve these is because it's not in standard form, so it might not be the quickest way to factor it. It's also not set equal to 0, so I wouldn't use the quadratic formula. And basically, I have like terms on either side. So if I wanted to work this out any other way, I would need to move this equation around a lot. So sometimes it's just going to be easier to use the calculator. You need to have the left half of the equation in y1 and the right half of the equation in y2. Now, one of the things that we're going to learn about in this unit is there's not always going to be a solution to the problem that's real. Sometimes our solutions are imaginary. So if you look at my calculator, I have the first half in y1 and the second half in y2. The other thing that you have to kind of work with on the calculator is your calculator only goes to 10. Sometimes our answers are not between -10 and +10. So I usually hit zoom 0 and then zoom out if you need to. But when I zoom, this is what I got. All right, now, anytime you're solving graphically, your solution is where they intersect. Well, this is a problem because my line does not intersect that parabola, which means if they don't intersect, you don't have a real solution. So for this one, there is no real solution because those two sides did not intersect. So let's try it with another one. We have 3x squared plus 1 equals 14 plus x. Again, I have like terms on both sides. I would have to do a lot of rearranging to make it look a way that I could use completing the square or factor or the quadratic formula. So I'm going to put the left side into y1. And I'm going to hit zoom fit. All right, and I can kind of see the line right along the bottom edge of the screen. I can see that it intersects once there, and it intersects again on the other side. So I need to find those 2 points. I'm going to use second trace 5. We've done this a lot in class, so you should be pretty familiar with these calculator buttons. Enter, enter, enter. And it's a good thing I chose to graph this because it looks like my answer is not going to come out to a whole number or a decimal that is easy to round. So I'm going to estimate and just call that -1.9. Anytime you're going to give me two x's, you have to put those squiggly brackets. Otherwise, one number would be an x, and somebody might think that the other number was a y. But we're solving for x. Quadratic equations usually do have two solutions, and this one does. So I need to hit second trace 5 again. But this time, I just need to move my cursor so that I go onto the other side of my graph. I need to find that other intersection. And it gives me about 2.2. All right, another way that we can use the calculator. Now, this one is pretty easy. We know that we can use the calculators to solve equations, and these directions tell me that I need to solve it. Another name for a solution is to find the 0. So now, other than it says 0, which I could easily cross this out, and say find the roots. Now you don't have that keyword anymore. This is the only thing they'll give you, is the function equation. And it'll say find the roots or find the zeros. So if you only have this one function, the only thing you can plug in is to y1. You need to remember that if your goal is to find the roots or to find the zeros, you need to put a 0 in y2. Otherwise, you could hit second trace 5 all day, and you haven't given the calculator a second thing to try to intersect it with. It can't find the intersection of just one thing, and it doesn't know that your question said to find the roots. You need to tell it to find the roots by putting that 0. I accidentally put mine in y1. But you need to have the function in one of your y's, and you need to put a 0 in the other one. And I'm going to hit zoom 6. Because I had kind of zoomed out a lot on the other one. All right, I'm looking for where it crosses the x-axis. You won't be able to see the line y equals 0 because it's the x-axis. But I can still do second trace 5, enter, enter, enter. And I get that one of my solutions is -3. Squiggly brackets because I'm finding two x's. I need to hit second trace 5 and scroll over so that I'm closer to the positive side. Enter, enter, enter. And I get +6. But if you don't remember that you need to put that 0 in y2, your calculator won't be able to help you. You could still graph the original function and estimate where it crosses the x-axis, but that's not exact. All right. Finding the roots or finding the zeros by factoring. The first thing that you want to look at anytime you have a leading coefficient, which means you have something in front of your x squared, look to see if it's a greatest common factor. Can I divide all of those numbers by 8? No, I cannot. So that means I'm stuck with it. If you can't cancel it out, the method that I use is called bottoms up. All right, the first step in bottoms up is to take the first number and the last number and multiply them. That's going to give me -40. Anytime you factor, what you're looking for are factors that add up to the middle number. If you remember how to FOIL, I know that these are going to both have an x. I'm basically trying to figure out what needs to go here and also what needs to go in front of my x, so that when I multiply them, I get 8x squared plus 18x minus 5. So I have -40. I need factors of -40 that will add up to +18. So I'm going to start thinking about the factors of 40, or I'm going to hit y equals -40 divided by x, and I'm going to go to my table and look for the whole number pairs because those are the factors. You get 1 and 40, 2 and 20, 3 does not go in evenly, 4 and 10, 5 and 8, and then you just get a bunch of decimals. One of these has to be positive and one of them has to be negative because they have to multiply to give me -40. All right, you should be able to figure out these are not going to give you -18. These two are not going to give you -18. The two that I need for my 2 to be negative and my 20 to be positive so that when I add them, I get +18. So now we want to check. If I decide on -2 and 20, does -2 times 20 give me -40? And does -2 plus 20 give me +18? If those two check out, you know you found the right two numbers. I'm going to set up my binomials. These are my factors. All right, those are the two numbers that I picked. But now here's the problem. If you try to FOIL this out, you're not going to get 8x squared plus 18x minus 5 because your leading coefficients right now are 1. The way we find that leading coefficient, in the beginning we had to multiply by the first number. At the end of bottoms up, we have to divide. All right, when I divide by that leading coefficient, I need to reduce. So I cannot do 2 divided by 8 evenly, but I can simplify that. I can simplify that to 1/4. All right, I can't do 20 divided by 8 evenly, but I can simplify that to 5/2. This is where I have to bottoms up. Whatever is in your denominator needs to get put in front of your x. That becomes your new leading coefficient. Whatever's on the bottom goes up in front of the x. So this factor would become 4x minus 1. And this factor would become 2x plus 5. Now we're not done because our goal is to find the roots, which means the same thing as find the zeros. Your last step is to set each of these equal to 0 so that we can solve for x. anytime you multiply one thing by 0, the whole thing is 0. So either this is 0 or this factor is 0. When you work this out, you get 1/4. When you work this out, you get negative 5/2. And those are your roots. So that's a step-by-step how you go through graphing and finding the solutions that way, and by using the bottoms-up method to find the roots.